In this video, we're going to learn how to use multiple exponent rules in the same problem. Understanding how to use several rules at once is important because the rules can simplify complex problems, making algebraic calculations faster and more manageable. Let's review some of our basic rules first. Here we have 2 times a to the 7th power times a to the 12th power. And the product rule tells us that when we multiply two exponential numbers or expressions with the same base, we add the exponents. Now, one thing to keep in mind here is this 2 out in front is 2 times a to the 7th power, so that exponent has nothing to do with the 2. So this will be 2 times a to the 7 plus 12 power. Normally we skip this step where we're showing the addition. So we have 2 times a to the 19th power. All right, here we have 2x to the 6th power, all raised to the 4th power. Now, this 4 does work on this 2. The 2 is on the inside of the parentheses and the 4 is on the outside. But we need to remember to treat that 2 like a regular 2 and not use the exponent rules on the 2. It's not an exponent. So this will equal 2 to the 4th power times x to the power of 6 times 4. Because when we raise an exponent to an exponent, or a power to a power, that's when we multiply. 4th power is 16, and 6 times 4 is 24. All right, here we have 4 times z to the 9th power over z to the 12th power. Remember, the exponent has nothing to do with a 4. And using the quotient rule, when we divide two exponential numbers with the same base, we end up subtracting the exponents. Well, 9 minus 12 equals negative 3. That leaves us with 4 times z to the 9 minus 12th power. 9 minus 12 is negative 3, so that's 4 times z to the negative 3rd power. Let's rewrite that without negative exponents. The negative exponent just means that we need to make a fraction and move the z's to the other location in the fraction. So the 4 stays where it is in the numerator, and the z's go down to the denominator, and when we move it, the exponent turns positive. Now, another way to think of this is there are more z's in the denominator, so if we just subtract the exponents and ignore the sign, 12 minus 9 is 3, those 3 z's will be in the denominator because we started with more z's in the denominator. Okay, here we have a quotient to a power, and that exponent applies to both the numerator and the denominator. So this will equal 5 squared over x to the 7th power squared. Okay, let's work that out. So 5 squared, that's 5 times 5. And here's where we multiply the exponents. So 25 over x to the 14th power. Okay, let's step it up a notch here. So we have b squared times 2b raised to the negative 2nd power. I think the easiest thing here might be to address the negative sign in the exponent first. So that means we're going to move the 2b to the 2nd power down to the denominator. So we make a fraction, and the b squared, that'll just stay in the numerator where it is in the question. And then we have 2b squared moves down to the denominator. And when we do that, it gets rid of that negative sign. All right, this 2 on the outside of the parentheses applies to the 2 and to the b. And remember, this is 2 times b. So we have b squared over 2 squared times b squared. Right, well, we notice that b squared divided by b squared equals 1. We're allowed to do that because there's no addition or subtraction in this fraction, leaving us with an empty numerator for now, and 2 squared equals 4. Since the numerator is empty, we'll go ahead and fill in with a 1 there. We get 1/4. All right, here we have a quotient to a power. Let's go ahead and do that first. Right, that 3 applies to the numerator and to the denominator, so I have 4 to the third power over a cubed to the third power. Let's go ahead and work out 4 to the third power. And we have a power to a power. We can work that out. And let's see, we could think of this 2a cubed as a fraction. When we multiply two fractions, we just multiply across the top and multiply across the bottom. And when we do that, this 2a cubed will just end up in the numerator along with that 4 cubed. So we'll have 2a cubed times 4 to the third power. That's 4 times 4 times 4. So 4 times 4 is 16. And 16 times 4 is 64. Then a to the third power, we have a power to a power, so we multiply the exponents. Let's go ahead and simplify this numerator. This is 2 times a to the third power. So we can go ahead and multiply 2 times 64. So that's 128. And here we have the quotient rule. So we have 128 times a to the, well, let's see, 3 minus 9 is negative 6. But we don't want to leave a negative exponent in our answer. So we make a fraction and do 128 over a to the 6th power. All right, no fractions here. So that's 3 times x squared times z to the 4th power. So this will be 3 to the 4th power times x squared to the 4th power times z to the 4th power to the 4th power. And it's all multiplication here, so we'll just keep on multiplying. We have 4 to the 3rd power times x to the 3rd power, and z to the 4th to the 3rd power. Okay, now we have a whole bunch of powers being raised to powers, so let's work those out. And we have 3 to the 4th power. Let's see, 3 times 3 is 9. We'd have another one of those, so that's going to end up being 81. So 81 times x to the 8th power, so we multiply 2 times 4. Z to the 4th raised to the 4th power, that'll be z to the 16th, 4 times 4. 4 to the 3rd power, that'll be 4 times 4 times 4, which is 64. X to the 3rd power raised to the 3rd power, so we multiply. And then z to the 4th raised to the 3rd power, multiply there again. All right, this is all multiplication, so we can do it in any order we want. So I'm going to multiply 81 times 64 on a calculator. And when we do that, we get 5,184. Right, I'm going to rearrange these because we notice that we have two expressions that are x's and two expressions that are z's. So I'm going to put the x's together. We're allowed to do that because with multiplication, you can do it in any order you want. And now we have an exponential, or two exponential expressions with the same base being multiplied, and that's where we add the exponents. So we have 5,184 times x to the 17th power, because 8 plus 9 is 17, times z to the 28th power, because 16 plus 12 is 28. So notice we are adding the exponents there. All right, I hope these examples where we had to apply several exponent properties have been helpful. This is Mr. Ela, signing off.